In episode 63 of MobiCast, John and Chris discuss service-to-service authentication for microservice APIs. Welcome to MobiCast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris. It's another episode of MobiCast.
Hey, John. Good to be back.
Yeah, great to have you. We're missing Rich today because we're doing this on a Friday instead of a Thursday, and Rich is busy today, so we'll miss him. We're going to talk about something that I'm pretty excited about because it's not something I know a lot about, and it is just... It's one of the things that I think makes working in microservices difficult. And it's, I think, the kind of thing that gets a lot of Google searches because people are like, oh, what do I do about this? So the thing is authentication for microservices. It's just have to do this, have to check this box. How do I deal with it? What's a way for me to not write any code and check this box? I think is a way a lot of people approach it, especially at the beginning of a project. So we're going to get into really, what are the ways of doing it and what are some good practices. And I hope to learn a lot through this. So, and because it's such a big topic, I'm hoping to get this in one episode. We're not going to find out what you've been up to this week, so it's going to be a mystery. Let's just get started, Chris. Tell us what we're going to talk about.
Cool, yeah, and we'll see if we can stick to that one episode goal. I kind of suspect this is going to be a two-parter, just because there's a lot here, and I'm kind of hoping it is. I mean, I think even though authentication kind of feels like security and kind of feels like a yawner, I think it's actually going to be pretty interesting.
This is different than security to me. This is the kind of people aren't like, how do I secure my microservice? They're like, crap, I know I have to do this, so let me Google how to do this. And like everybody's trying to figure this out. So I think it's different.
Yeah, I mean, and I kind of think this is more like just API design too, right? Because, and just as you asked for, like originally I set this up. So really, I mean, this is we build microservices. We do APIs, whether they be RESTful or GraphQL or RPC based or whatever it may be. But you're going to have endpoints that maybe you do have some that are anyone can hit, right? You don't need any kind of identity to them, so they're not authenticated. But by and large, you're probably building APIs that should be authenticated, right? Like even if for no other reason you want to just do things like just being able to do rate limiting, right, and quotas, and just keeping track of like who's calling what. So chances are most of your APIs are going to require some sort of authentication. You need some identity associated with that. So it's fundamental, right, to the APIs that you're designing. And normally when we think about identity, you have a user context, right? So it's the typical client server type application. So you got some front end JavaScript client, web client, maybe built it in React or Angular or some other JavaScript framework. It's doing things, and it's now making API calls to some backend microservice. And so as it does that, it's doing it through the context of a user. And so it's, John Smith, and they've signed in somehow and provided identity. And it's very clean and crisp and clear and easy to understand. So that's
even if there's dependencies there, like one microservice calling another one, they can preserve that user context from call to call to call as long as they're all synchronous, right?
Oh man, you're that's actually another big can of worms that'll be kind of interesting. Maybe we can circle back on that.
Okay.
Like, do you actually pass along the context of who called you as you have a chain of microservice calls, right? And so you can do that, and there's pros and cons to it. Versus, do you not bubble that context down, and instead is it now becoming a service to service call? So maybe we. If we have time, we can circle back to it and talk about it. That's one of those implementation things that gets really hairy quick, and it gets actually really complicated. So I'm kind of glad you brought that up, but maybe we'll circle back on that one. So yeah, so you have this. So broadly, there's two types of authentication that we have with our microservice, our services, and our APIs, right? So we just talked about user authentication. And so that's when you actually have the identity of it's an actual end user, right? So, and the identity mechanism is coming from some well-known system, right? And there's lots of plumbing out there for doing it. So you can use something like an identity as a service provider. So things like Auth0, Okta, OneLogin, even like AWS Cognito, right? These are all just existing off-the-shelf systems, frameworks that you can use to implement your user profile, your user identity store, type thing. You can use things like OAuth or SAML, security assertion markup language systems to do identity and things like single sign-on. And just at the end of the day, you have these end users. They're registered with your system somehow. They have accounts, and they're providing credentials. It's a user ID, password. In exchange for that, like, we now have a well-known identity, and that context is what gets passed to our microservices. So that's user authentication, and that's the common path, and that's the well-known path. And we're not going to spend much more time talking about that because that's a pretty well-known, easy to solve problem. What we really want to focus on in this episode is what happens when the callers are not actual users, but they're other microservices. So let's call this service-to-service authentication. And so this brings up an interesting problem. Like, how do we give these callers identity? So it's definitely this is a common thing. Well, once you start building out like services and definitely have more than a handful, you run into this issue where you're going to have, as you do your refactoring and your architecture and design, you're going to have like core services that provide services to other microservices, right? So it's now the service becomes the client of this other service. And you can kind of think of it maybe as like a hub and spoke architecture, or again, just as a natural progression of your design. As you have more and more services, this is going to be more and more of a common occurrence where you're going to have other services will need common functionality, and then they go and make they need to make API calls to these other services. And so how do we handle identity there? And that's what we want to focus on in this episode.
Cool. Can you give us just off the top of your head, an example of, a service that we can understand that would need to call another service, like just some real world example?
Mm-hmm. Yeah. I mean, a real one would be configuration state. So imagine like you wanted to have a way of handling configuration in a real-time way across your applications, right? So it could be silly, like just whatever it may be, like settings. So you could have like for us, like a real example is we have an application that allows export of data in CSV format. And for various reasons, we need to be able to limit how the scope of those exports, right? To limit the amount of data that's being done. So we have some configuration setting and say, hey, let's limit it to 3,000 rows of data. And so that's a configuration setting. And typically you would do something like just add it as a config file into your service. Maybe it's an environment. Maybe you could do it as an environment variable. There's lots of techniques. It could even, you might want to do it as maybe database or something, but usually, yeah. And then there's that too, right? So, but the point being is, like, for the most part, like that config, like that's going to be something where if you want to change it and say like, oh, instead of being 3,000, we find out it's really we want to bump it up now to 5,000, that may be a code change and a redeploy to change that. And so it'd be really nice to have kind of more of like an admin UI where you could kind of change, some administrator could go in and just change that. And when that setting is changed, push the changes out to anyone that is interested in that, right? So this way, in real time, it can get the config update, and that's now live, right? So you might have this microservice that's responsible for hosting that distributed configuration, for allowing other folks to register with it and say, give me my configuration, and then also to register for callbacks when changes happen, right? So that would be one of these just kind of core, that configuration, that distributed network configuration service would be one of these hub microservices that other microservices are going to be callers of. And Again, we want to lock that down, have authenticated APIs, know who's calling it. And so that would be a one such example.
Okay, cool.
And this is the crux of the problem, is like, so how do we give, these callers identity, when it's another microservice that's calling? And this is where it's like the wild, wild west. There is just, like, this problem has kind of been around for a while, especially once we kind of switched from monoliths to, the microservice buzzword, and which is basically just kind of like just making our services refactored just as we would good code. And
I think
so
I'd like to characterize this problem too with sort of an attitude from about 10 years ago of like, it's all in our own data center. It's all, kind of safe. So services can call each other, and maybe we'll throw in an API key. And that'll just make it safe. And that's kind of like how I think things got dealt with for a long time.
Yeah, and I actually think that's how they still get dealt with too, in the majority of the cases, right? So, and that's a great point. I mean, that's definitely one of the various possible ways that you could go about doing this. That's definitely one of them, right? And it's probably one of the more common situations is just like, we're not going to do authentication for service to service calls. So we'll lock it down from a network perspective, and that we handle it that way, right? So we make sure that so we're not dealing with identity, we're really just dealing with security in that sense, right? So we don't necessarily know who's calling us, but we know that whoever's calling us, it's from the allowed space.
Right, they have the keys
right?
to the building.
Yes, right. So that's absolutely one of the possible things, that you can do, and what people have been doing. Other possibilities are, now with things like the service mesh becoming more popular, and we talked about this in previous episodes, that's providing this functionality, right? So in particular, Istio we talked about Istio and it's one of its components, Citadel, that deals with security and identity. It uses X509 certificates to basically give identity to each one of its components in that system. And it's actually using something called SPIFFE. And SPIFFE is a new standard. It's not. I don't think it's not. It's still going through that process of being defined. But it's a group of folks that are in this space of like, how do you do secure identity for the components of a distributed system? And SPIFFE stands for Secure Production Identity Framework for Everyone. And so this is absolutely being built for this exact problem.
I want to characterize the problem a little bit more, just because it's like, I had just made the joke of like, you have the keys to the building. And I think that is a good analogy, because now the building is the cloud, and it's multiple regions, and it's multiple availability zones per region, and it's maybe different networks that are peered together. And are you sure that your network engineers tied everything down so nobody can get in? Like, are you really sure? So no, I'm not sure anymore. Like, there's so many firewalls running and so many things that could potentially get left open. I better make sure that everything that I'm running protects itself.
Absolutely. Yeah, absolutely. I mean, and again, there are the two pieces to this, right? One is the security aspect of it, making sure that like who's calling me is allowed to. But then you also have the identity part, right? Like who is this service A or is this service B? Or is it just some anonymous caller that I'm pretty sure is allowed to call me, right? That has the keys to the building,
right?
Thing. So there are those the two pieces to it. And as you mentioned, I mean, it's securing your cloud is not an easy job, right? So having that approach of just saying like, okay, I've secured my cloud and just allow requests coming, just don't deal with authentication. Like that's kind of fraught with issues, right? So SPIFFE is this standard that's being developed by a consortium of folks, and it's comprehensively dealing with this issue, and it has its own various components, right? It has ways of creating identity namespace, and it has ways of doing identity documents, which at the end of the day are either X509 certs or they're signed JWTs. And then it also has an API for talking about how the components in the system can issue and make these requests, right, throughout the system. So I guess the main point here is that it's not lightweight. It's pretty. Again, it's kind of a pretty complicated, comprehensive system. And if you're a bigger company with lots of folks to work on this stuff, then like this is something you definitely want to go look at, because it's kind of like what we talked about with the service mesh, right? It's
if you're a bigger company and you have lots of folks to work on this, please do, so that it can be easier for the rest of us, and then we can start using it. It's not there yet.
Yeah, indeed. So there's that. You have, there's other kind of more comprehensive, complicated ways of dealing with this as well. So you can do things like OAuth 2 and have specific service accounts and do the exchange back and forth and have these accounts and negotiate for the credentials and use that as your identity. But again, quite a bit of work to go implement your own OAuth 2 implementation, right? And then you have more kind of like vendor specific ways of doing it. And this is kind of along the lines of your analogy of you have the keys to the building. But like if you're in AWS or Azure, you can use things like IAM roles and security groups, right? To lock down who can call who. Those kinds of approaches do run into some complexities if you have services that can be called by both users and other microservices, right? So there's some, like, how do you deal with that? Like you have certain API, like if you have authenticated APIs that sometimes you are going to have user context and sometimes you're not because it's a microservice. So how are you going to deal with that at the IAM level, security level? It gets to be a bit trickier, right? So those are the more comprehensive, complicated ways of doing it. And I think, again, for the purpose of this discussion, that's all we need to say about that. Because I'd now like for us to focus more on let's talk about some more kind of like the simpler approach, some simpler approaches to this that would be perhaps more suitable and practical for most folks out there. Because most of us don't work at Netflix. We're not at Google, and we don't have thousands of microservices. It's really more like a handful.
Right. And I also want to say that these approaches that we're about to go over can probably still, get past the security audit by like a qualifier if you're building a payments application. It's not that they're not secure. It's just that they're maybe easier to approach from a development perspective.
And so again, great point, because now that's absolutely true. And not only is it's actually like what we'll talk about forms the basis for some of those other systems. So and specifically something like SPIFFE, really at the end of the day, SPIFFE, it's either X509 certs or it's signed JWTs. And we're going to talk about signed JWTs. And so it's very, very similar to what SPIFFE is going in and basically trying to formalize. Mm-hmm. Right. So we're just taking a piece of it. We're not going to go make it adhere to any one particular standard and deal with all the various edge cases that they've thought about. Instead, we're just going to keep it at a practical level. But at its core, from a identity, from authentication standpoint, it's the same technique and it's just as valid. Another point of reference, if you will, is like these signed JWTs. I mean, this is actually one of the things that Google recommends for service-to-service authentication for their Google Cloud and OpenAPI, like this exact same technique. So even though again, these are simpler, it doesn't mean that they're any less valid or secure or robust.
Cool. So yeah, tell us more.
All right. So given that, I mean, there's two simple, we'll call these the simpler, more practical approaches for service-to-service authentication. And let's call them, the first one is basically just API keys. And then the second one we'll call signed JWTs. And so first, why don't we talk about API keys? Because I think this is something that's pretty common out there. It's pretty well known.
They're in your email. They're in your GitHub account.
Yeah, I mean,
they're everywhere.
Yeah, I mean, if you're using something like an email sending service like Mailgun or MailChimp or whatnot, chances are you're registering to make API calls using an API key for them. So they give you an API key and that ends up becoming the identity for it. Same thing for like a lot of webhook type systems and whatnot. So in this particular case, you're basically, an API key is just, kind of like this machine generated. I mean, it's a password is what it is, right? And so that password identifies your identity as well. So it's basically it's a unique value that's generated by whatever issued it. And it knows when it gets issued, you're basically saying who you are. So by that one unique value, you're getting basically both identity and, the verification that you are who you are by virtue of the fact that that secret, that password. Mm-hmm. And so that's really what an API key is, and really easy to implement, right? Because it's basically just a password. So, the most common way to do this is just throw it into the HTTP request header, into the authentication header. and put your API key in there. At its core, that's not secure, right? Because it's just base64 encoded, but you send it over TLS and now it's encrypted. And so it ends up being a pretty good, decent way of handling the identity and authentication issue. As long as you're going over TLS, it's secure. And so, it works. It's easy. And again, this is pretty common, pretty popular. You'll see it out there. It's really easy to roll your own as well. But, there are some downsides to this. And so, one is like you now have to manage a list of these keys, right? So you have to decide what's the level of granularity for these keys, or do you have like and this is for you, you the implementer to decide for your system. Do you have like one API key for all your services? Do you do it on a per service basis? Do you issue them to individual callers? And it really boils down to like what level of granularity you want for identity. And then also like what is the blast radius from a security standpoint if the key gets compromised. So those are the kind of things you have to figure out. It adds complexity for how many keys you have to manage. It makes it much more difficult to do things like rotation of credentials, the more keys you have, and just, how are you going to do this given that you're managing?
They're probably hard coded into people's code.
And that's another that gives to another con with these API keys is that at the end of the day, they are something that like developers need to know. So you need to pass them around like, hey, what's the API key for hitting this service on staging? And, so now how are you going to share that? Do you do it at Slack? Is it a DM? Is it chat? Is it email? Do you use, you should use something like LastPass, some secure password credential sharing service. But who knows? Maybe someone in test code accidentally commits it to GitHub, right? And then now you're host. Now it's time to do rotation. Yeah. Right. Yeah. So those are some of the definitely the cons that with API keys, and one of the reasons why in general we don't use that method. So simple, you can make it work. Just know that there are a laundry list of disadvantages or gotchas with it that you'll have to deal with.
Hey there, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 30,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head on over to iTunes to leave us a review. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
So the second approach I want to talk about is the signed JWTs. And this is something that we have done here at Calsys with this pattern, and it's worked really, really well for us. And it's also been the most similar to kind of keeping parity with the other form of authentication, the user authentication. So, at the end of the day, the user authentication ends up looking like a JWT, and with things like, just identity stuff, like, what's the account name, maybe it has information about the user, like first name, last name, email address, that kind of stuff. We can kind of do the same thing with the JWT for our service authentication. So we can give things like what's the name of the calling service and information about it, and perhaps even things like what roles it has and levels of access or whatnot. So some additional information about the context of the call. So having a JWT gives us that flexibility, and we can actually go build like a separate microservice for handling some of those things, for issuing these JWTs, and be responsible for doing things like, okay, what are the roles and what is the level of access, and not just authentication, but get into things like authorization. So pretty flexible, but also you can keep it really simple as well. And so
I think maybe some people listening might not know what a JWT is, a JSON Web Token. Can you tell us what that even is? Yeah,
so like I said, it stands for JSON Web Token, and really all it is it's a JSON document that it's basically composed of three components. So it has a header, which kind of indicates one, that's a JWT. So it specifically says that this is what I am. I'm a JWT. And then it also says what's the cryptographic algorithm for signing this. So that's in the header. The payload for it is basically where the claims go, and the claims is basically the identity information. So, and there's some very well-known claims. Most of them are 3-letter abbreviations. So, but at the end of the day, they indicate who they are, who they're trying to talk to. And then you can have like the standard claims in there, the standard properties of the claims in there, or you can extend it and add your own unique things that you want to put in there. But that's really
like 3-letter claims. I can't even imagine what that would be. Like, can you think of any off the top of your head?
Yeah, I mean, so like some of the common ones are EXP, right, which stands for expiration. So it says this is how long this JWT has its TTL. Another one is AUD, AUD, stands for audience, and that is like what's the name of the thing that I want to talk to. Sub, SUB, I think that's probably like short for subscriber. And that really is we use that for the name of the service that's making the call, right? So it's the client, if you will.
And it's the service that's making the call that initially constructs this JWT, right? It's like going to put one together and send it to the service that it's calling, and the service that it's calling is going to basically evaluate it and make sure that it looks right.
Yeah, I mean, in the kind of like the simplest way of doing it, if it's just two services talking to each other, it's the initiating service, the calling service that needs to kind of put together its identity document, and that's that JWT. So that JWT gets created, and that gets sent with its request. And then on the receiving side, it can then look at that JWT and decide whether or not like this is valid and to allow it. So those are so we talked about the header part, we talked about the payload part with the claims, and then the last part of it is the signature, right? And so this is the calculation. This is based upon like the way the cryptographic method I used for signing this using a secret. Here is the signature, so that basically I can. This is where the authentication part comes in, right? To verify the identity and the integrity of the claims within it by having that signature portion of the JWT to be able to basically run the same algorithm on both sides, both the initiator and the receiver run the same algorithm using the same secret basically password. And if they come up with the same result and that signature matches, then they know that, hey, we're allowed to talk to each other, right? I know that whoever sent me this is who they are by virtue of the fact
that whoever sent this has the password. It could be that somebody else has it too, but
sure.
You don't know that they are who they are.
Sure, yeah. So it's they have the password, and so which is as good as we can do in this, and that's kind of like as good as we can do
in the world
anywhere, right?
now.
Yeah. So absolutely
cool. So actually, I hadn't really gone all the way. I haven't implemented JWT before, so that was a nice little lesson for me. Thank you.
Mm-hmm. Yeah, and we've kind of covered the bulk here of like just what this approach is, right? So it's really so from a caller standpoint, when they want to make a call to another microservice that's expecting authentication, it's their responsibility to construct one of these JWT, these identity documents. So the really key part of that is that they need to be able to sign it, cryptographically sign it, and they have to use this shared secret. So it's got to be a secret that's known by both the recipient as well as the caller. Again, this is the password, right? And this is something that you need to protect and make sure that the scope is limited to who can use that. And this is where you can leverage just the various ways that you can protect things, throughout the system. So you can use like a secrets manager, like something like Vault from HashiCorp or Secrets Manager from AWS. You can use things like S3 buckets and policies and kind of lock that down. And you might say like this service is only allowed to be called by these 3 other services. So only allow those three other services to access that S3 key.
And as you're explaining this, and as I'm learning this, I'm having these aha moments about what JWT provides that is so cool. If you were just to have, say, like a username or like a ID, then it would be the responsibility of the caller to kind of keep a record of who's who. So, ID 1456 is, that's the configuration client that we had set up before, and it's stored in this database that I keep because I'm the service and I have to know who everyone is. Whereas with JWT, it seems like you can get new callers without having to kind of maintain who they are. They can just, as long as they meet your specification, like, so you have to say, well, you got to tell me your name. You got to tell me, maybe you can even have it tell you other things like where you are. Like I'm in AWS region, US East 1, and this is, A, my availability zone. You could do all kinds of cool things, additional information you could put in that JWT, and then all that information could be loggable, but it doesn't have to be, and if it's not there, you could say, well, you gave me the right key, everything was signed great, but you didn't include the information I wanted in the JWT, so you're denied. Sorry. Like pretty cool. You can do
yeah, absolutely. So very, very flexible, right? Like that was kind of like definitely one of the points of the cons with API keys is that you have to maintain that list of keys, and those list of keys are both the identity and the authentication. So that means you have probably some database table that's keeping track of this particular API key. This is the description of who that user is or that caller is, right? And some meta information about it. You have to, maybe that's where your TTL, you have to have TTLs on it. I mean, just all the information that goes along with that versus with the JWT approach, you're basically saying that information is the responsibility of the caller, and they can actually put whatever they want inside there, right? They can say whoever it is they want to be. So it's up to you when you're designing this and coding this, like just, you need to have some conventions, and you need to have a reasonable way of doing that. But this particular approach is just it's not saying one way or the other, right? It's really what it's guaranteeing is that through that shared secret, it's basically verifying that both parties have that same shared secret. They have access to that shared secret, and therefore they're allowed to talk to each other, and therefore it's authenticated, and it's passing the identity information in that JWT, and that identity information came from the caller. And it's completely flexible and extensible. And like you said, the receiver can be like, well, I'm now expecting, I need this other thing, right? Maybe now I'm implementing RBAC. Roles-based access controls. And so I need a list of roles that come through on that as well. And again, you can have something like another microservice that's responsible for generating your JWTs, right? And determining not only authentication, but also authorization. So lots of flexibility there with this kind of approach. And the great thing about it is that you don't have to do any re-architecture or design, right? Like you can extend all this with really no changes to the rest of your system. So if you want to have some standalone microservice that's responsible for doing your JWT generation, and it's the one that is knowing about secrets and keeping track of who can call who, like that can all be done without really changing the recipients. Right, the services that are being called, they don't care. They're still just getting the JWT. They don't care whether it actually was created by the caller or the caller used someone else to generate it.
And if the JWT doesn't validate, it's not signed right, or it doesn't have the contents that you're expecting, then you can send, if you're using HTTP, you can send back which I guess you would be with JWT, send back a 401.
Absolutely, yeah. So that's what these recipients, the services are doing. Like they're getting that JWT. Again, it's coming across in an HTTP request header. So use the authentication header to pack that JWT into it as essentially, the password information, if you will. And again, this is going to be going over TLS, so it's encrypted. It's going to extract that JWT from the header. It's now going to do a decode operation on that using its shared secret and compare it to the signature that's in the JWT. And if they all match, then it says, okay, this thing's valid. And that's authentication identity. It could now do another. And so if that doesn't work, right, if it's not valid, if the signature is incorrect, if the decoding fails, then it can just reject it as a 401 unauthorized. If it does succeed, then if the service wants to, it can now go further and say, okay, I know who this identity is. do I want to do further checks to now do to perform more to do authorization checks, if you will, right? Like I can now put in rules like maybe I'm only going to accept requests from these two services. So if identity is not that, then I can reject it there. But that's, again, extensibility of the system and however you want to do it.
Right. It's not in our outline. And so this is maybe putting you on the spot a little bit. But if somebody's listening, they want to implement this and they want to just sort of, get a bit of a head start. Do you have anything that you would recommend that they look up or look for in order to not, reinvent the wheel when it comes to implementing JWT as microservice authenticator?
Definitely use a JSON library, a JWT library for handling this and for handling the encode and decode stuff. There's just tons of libraries out there. So don't go and try to re-implement the wheel. It literally is for almost whatever language that you're on, whether it's Ruby or Java or Node or .NET. It really should be, to do this creation of a JWT or to do the decoding of it, shouldn't be much more than 10 lines of code using one of these libraries. And go to jwt.io, that website. That is a great website with lots of information. It's I believe it's hosted by Auth0, and they may be one of the original backers of the JWT spec. And they have they have their own libraries that are out there that are open source and available, but every platform out there has libraries for dealing with JWTs and for assigning them, for encoding and decoding them. So definitely use that. Really, it just boils down to what is your mechanism for distributing the shared secret and making it so both the caller and the receiver know about it. That's going to be you're going to roll your own on that. Just whatever you do, make sure you've thought about that and you limit the scope of who has access to those shared secrets. And also kind of basically make it such that like developers don't need to know that. Make all access to that just make it programmatic through code. And so it makes it a little bit more challenging for developers. Like they can't just do an ad hoc curl statement. They'll have to probably run a script to go generate a valid JWT. Mm-hmm. But it's so worth it because it's like just let the code go and make the secure fetch to get the shared secret to go make a JWT, as opposed to passing around the shared secret so that anyone can then go and do it. So yeah, leverage the library codes that are out there for dealing with JWTs and signing and for encoding and decoding, and then really think hard about how you're going to protect your shared secrets.
Yes, for sure. And so I think that kind of covers what we wanted to talk about in terms of microservice authentication. But and so if you're done listening, thank you. But there was that one part that I'd like to spend just a few more minutes on for those people that have time about, well, if you have a chain of service calls and you've got a user context in the first one, and then services are calling each other after that in a chain of dependencies, wouldn't you just kind of pass that credential along from service to service? And I think that I kind of understand now what the answer might be, is that instead of doing that, we could maintain that context as part of our JWT information from one service to another, instead of like using the actual original JWT that had the user's context in the first one. Before you answer, I guess I want to preface this with saying, if there's a deep down dependent service that's been called by several other services before it, but it was all initiated by a user, I would assume that in our architecture and in our information gathering systems, we would care about who that original user was. Like, to lose that information would seem to be a bummer. Like, some database gets updated and we sure hope that we know that it was Charlie that really wanted that database update to happen, even if it was like microservice XYZ that ultimately made the call to update the database, right, Chris? Like, we do want to know all like that user information, right? Even deep down in a list of services that have dependencies, we want to remember that because that's important.
Yeah, again, this gets into kind of just implementation considerations and just where it has to deal with your architecture design and just the various microservices and how cohesive they are with like the user model, right? So like I think like a good example of this would be, like, and this is like a real world example that I ran into in the past. So imagine you have a photo sharing application. And so and let's just say that the way that this gets designed, because so photos end up at the end of the day are a certain type of image, right? And images are, at the end of the day, it's just a binary file, like let's just call it a blob, right? And so you can think about, as you're thinking about in that system, maybe it makes sense to, like, this is actually 3 different services. Maybe I have like I have my front end, my application service that does all my application specific logic around photo sharing, right? And all the things that it can do there. Maybe I have a separate microservice that all it knows about is just images, and maybe all the functionality it has, like things like image filters. It can do things like resizing. It can do effects. It can do things like flip and crop and stuff like that, right? So just anything around images. And then maybe I have a third service that all it's responsible for is blobs, and its responsibility is making sure that I have, just the ability to do CRUD on blobs in a very scalable way. And so the image service will use the blob service, and the photo sharing service will use the image service, right? And so that's kind of like the chain. And so you definitely have user authentication coming in on the front end to your photo sharing service. Now it gets tricky. Like, do you still pass that same user context down into your image service? Like, did you design the image service so that it had the exact same user base? And is it really?
Doesn't matter. Yeah.
Yeah. Right. And it gets even more tricky, like going down to the blob service, right? Like, was that really designed with that in mind? And it shares the same user database as your photo sharing service. And so at some point there's a breakage, right? Where it just doesn't keep extending, right?
Yeah, sure.
There needs to be the separation. Yeah. And so that's where it comes. So you have to decide, at what level in my system am I doing that? What's responsible for doing the authentication and the authorization? And so, you may decide that that's all done at the front end, at the photo sharing service, and all the identity, all the authentication, all the authorization questions are handled there. And then at that point, now the authentication is done at the service to service level between it and the image service, and also between the image service and the blob service. So they're just saying, like, we don't really care about users. Like, we don't care about that user's context anymore, that data, because we don't even know about that database.
Got it. Yeah. Right? So it seems to me like sort of the way to break it down, or the rule of thumb, is that if your microservice is acting on stuff that might change the state of a particular user that's using your app, then you would want to have that context. But if your microservice is doing kind of what you might call generic work, then who cares? Let it do generic work. As long as it knows what other services are asking for that generic work, then you're good to go. Yeah.
Like at the end of the day, it just really boils down to like architecture design, but it's one of those things where it seems like, like the natural inclination is like, just pass the user context down, and it's really easy, right? Like you just
yeah, that's what
the blob service knows that is John Smith that made the call, but it's like when you get to implementation, it's like, wait a minute, does blob service, how does it know who John Smith is, right? So now that it gets pretty complicated pretty quickly.
Makes sense. Well, cool. I think that's a good sort of way to round it out.
I think so. I think we actually got through a lot more than I thought we did. Although I have no idea how much time we've spent, but it's gone by quickly for me. Hopefully,
people are sitting waiting to try to get into the go in for dinner at this point.
Yeah.
It's like sitting in the driveway listening, I hope.
If only, yeah.
Right. All right. Thanks a lot, Chris. I'll talk to you next week.
All right. Thanks, John. See ya.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/63. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.